Hello, my name is Muhammad NURIHSAN bin YAHAYA and my other friend is Muhammad RAFIQ bin RASHIDI. Today, I am going to present our mini project given by the title of Low Power Consumption Pedestrian Crossing Light. Traffic light is a signaling device positioned at a road intersection, pedestrian crossing or other locations. It is to indicate when it is safe to drive, ride or walk using universal color codes. The universal color codes are red, green and yellow, in which red light means stop, green light means go, and yellow light means ready to stop. Next, pedestrian light only have two lights, which is green and red. But nevertheless, for this prototype we added another light, which is the yellow light. Traffic light gives many benefits to all users, such as reducing the number of accidents, making the traffic flow smoothly, and possibly could save people's times and lives. To manufacture a pedestrian crossing light, there are many problems that may be encountered by engineers or installers. Therefore, we need to create a problem solution for each of these problems. This is how the schematic circuit design looks like, with the solar panel acts as the solar panel acting as the main power source and the 5V DC as the second power source. This is how all the circuitries looks like, which features the traffic light, the pedestrian light, the Arduino Uno, which is the microcontroller, a pedestrian button, a two-way relay, a flyback diode, and two main sources or power sources, which is the solar panel and a 5V DC battery. In real life, the solar panel is actually 240 volts of DC, and the 5V battery is actually 240 volts of AC from the TMB grid. Now, because this is only a prototype, therefore we only use 5 volts of DC for the solar panel and 5 volts of DC for the battery. And the main power supply is actually the solar panel here, and the second backup power supply is the 5V battery. Now, from the connection here, there is actually no connection between the Arduino and the VCC ground to the battery or the solar. This is because at each of the digital pins here, there's already 5 volts of DC supplied by the Arduino, which is embedded in the system for the simulation. Now, for the relay, whenever the solar panel is out of power or juice, then it will switch from solar panel to battery. This is the use of the relay, and for the diode, it actually blocks currents from flowing backwards back to the relay and turning on pedestrian buttons without pushing it. So, preventing current from flowing back, a diode is placed here so that the current will only flow in one direction. Now, for the simulation, after doing the coding, which is here, the codes must be compiled. Then the hex file should be placed inside this microchip or microcontroller in the format of hex file. Then we can run the simulation. Now, the pedestrian light is actually in red and the traffic light is in green, indicating that vehicles are now moving and people are now standing still or not walking. Therefore, when a pedestrian presses the button once, the light will change from green to yellow for 5 seconds, indicating vehicles to start moving, and then from yellow to red, and then from red to green. Now, pedestrian can start to walk for 15 seconds. After 15 seconds have passed, the green light now changes to yellow for 5 seconds, telling that pedestrians must start walking before the pedestrian light turns red. Now, after it turns red, the traffic light will now turn green and our vehicles will start to move. And there you go. Now, After doing the simulation, this is how the PCB design looks like, and this is the output voltage at each of the LED, power source, and the button when measured using a DC voltmeter. Next is the amount of power consumed by the LED, whereas when measured is given by 25.7 milliwatts. This is because the voltage of an LED is given by 2.2 volts and the current is 11.5313 milliamps. And using the equation of P equals to IV, we get the value of 25.7 milliwatts when calculated. Next is the power consumed by the resistor, given by the equation of P equals to I square R. After substituting all the values here, when calculated we get almost the value of 29.3 milliwatts when it is simulated. Thus, the total power when added is equals to 55 milliwatts when it is calculated, and when it is simulated it is equal to 57.7 milliwatts, which is almost equivalent to 55 milliwatts when it is calculated. Then we change the LED with a bulb to know or to identify how many watts does the bulb consumes over an hour, and when simulated it consumes about 104 milliwatts. Note that the supply we give on the bulb and the LED is only 5 volts, but in real life it is actually 240 volts of AC. Therefore, the watt or power consumed by the LED or bulb might be higher in real life. Now this is how the theoretical values of LED when calculated looks like. The calculation of theoretical values for lamp or a bulb. And this is the comparison in which LED actually consumes less power compared to a bulb, 28.006 milliwatts and 78.64 milliwatts. Now, these are the safety awareness when installing or when designing or manufacturing the prototype. In real life, there are several hazards that may occur to engineers or installers, which are falling from heights, dealing with high voltages hazards, or getting hit by a vehicle during traffic pedestrian light installation. First of all, falling from incredible heights. It is advisable for engineers or installers to use fall protection safety such as hook ropes and non-slippery boots, because we are dealing with high or tall buildings when installing solar panels, or when we are installing pedestrian crossing lights or traffic lights. In those conditions, engineers or installers can use sky lifts or crane to move a person or object from ground to high places instead of using ladders. Next, when dealing with high voltage hazards, installers or engineers should be aware of hazard when dealing with voltages of 240 volts of AC or DC. Therefore, they might need to wear insulated safety equipment such as rubber gloves, insulated ladder, and safety boots. Next is during the traffic or pedestrian light installation. Thus, installer or engineer should be aware of this traffic situation to avoid from being hit by any vehicles. Therefore, they need to at least place cones or roadblocks or lights at least 100 meters away from the installation light, so that they won't be hit by any cars during the installation. And these are the some precautions to protect against potential fire hazards when installing solar panels, which is to purchase quality components, hire an experienced installer, route cables properly, protect inverters, inspect regularly.